We are the Goldberg Boys. We will be presenting our Battle Frog Rube Goldberg project. I'm Ben.
I'm Braden.
And I'm Sam.
To give you a brief introduction of this presentation and what it will entail, we'll be talking about our Battle Frog Rube Goldberg machine, our project planning and management exercises, our company goals as far as what we want the product to do, what we want to sell it for, our cost analysis, basically how we broke down our cost, and design phase 1, which is the first design phase of 3. For our planning exercises, we each came up with a concept of what we wanted our respective Rube Goldberg machines to do. Braden and I geared ours towards elementary and middle schoolers and things that they learn in math and science. Sam's was geared more towards high schoolers and physics classes, and we ultimately decided to go with that one because we felt that there was more of a market for that kind of product. For our project, we had an 11-week span, and basically some things we had to look at were customer needs, economic analysis, prototyping, and presenting our final product. I'll hit more on those in our Gantt chart here to follow. So basically you can see we have quite a few items in our Gantt chart here, starting off with identifying our customer needs for the physics product. After we do that, we can work on establishing specifications based on those needs, and from there, concept testing, concept generation, prototyping, economic analysis that goes on throughout the product as things change, and finally presenting our results as we finish up the project. A use case basically is a document that has how the product is going to work. It's going to consist of 3 stations, each one demonstrating a different law of physics. Our first one is going to have projectile motion. The second one is going to have conservation of energy, and the third one is going to cover Newton's third law, which is the sum of the forces equals mass times acceleration. And basically there's going to be an interactive way that students can calculate problems, choose the correct answer, which when they choose that correct answer, it'll cause the ball to move forward. If they choose an incorrect answer, the ball won't move. It won't move until they choose that correct answer. Choosing all the correct answers will cause it to go from start to finish.
So this is our design phase 1 here. So the ball is going to enter the chamber right here at approximately 3.4 meters per second. It will then be loaded in to where the spring is here. The students will be given the spring constant. They will be given the distance up the ramp and the angle of the ramp. And the students will have to calculate the minimum force needed for the ball to go up the ramp and then go down this ramp here to proceed to our next design phase. In terms of customer needs, we interviewed 6 potential customers. These customers being high school physics students and high school teachers. Common complaints and the reason that we're making this product are textbooks are boring and expensive, and we're trying to make this a more interactive product, something to keep the students more interested. In terms of interpreted needs, like I just said, trying to make an interactive learning device rather than just listening to lecture notes all the time and being bored and having notes drug out over time. We're just trying to create a better way and a more fun experience for physics. Also, the product must be affordable. We're trying to keep it within that $70 to $90 range. In terms of product specifications, we have a 24-inch by 24-inch base area. Also, the ping pong ball must be received at a velocity of 3.4 meters per second. Has to utilize an Arduino, so when they answer the minimum force needed for the ball to go up the ramp, that is what the Arduino will be involved with. Must be affordable, like I said, must be within that range of $70 to $90. Has to reinforce the physics concepts that we talked about earlier. And in terms of longevity, we're trying to make this product last at least 5 years.
Okay, for our economic analysis, we wanted to focus on a scenario 2 concept, which we're entitled for that. The cost is going to be dependent upon how many products we sold. Our formula for this was 170 minus 0.5D, D being the amount of products sold. For this price, we wanted a target price between $70 to $90, something in that range would be ideal. And with that, our max profit using the scenario 2 would be around $1,550, and that would be from 160 units sold. To make a profit, our break-even points would have to be between 110 and 210 units. As you can see here on the graph, it shows both the total revenue and the total cost. And in areas where the total revenue exceeds the total cost, as seen here, that is where our profit will be.
So in summary, moving forward, our first design phase prototype is due next week, October the 18th. Design phases 2 and 3, which will cover the second and third physics concepts we talked about, will be due the respective Wednesdays, October 25th and November 1st. And our project should be completed on or around December 13th, which will include our final product. Thank you.